Okay, in this section, we're going to talk about a specific kind of sequence called the arithmetic sequence. And an arithmetic sequence is a sequence in which any two consecutive terms has the same difference. And this is known as the common difference. And we denote it with the lowercase d. When we write down the nth term for an arithmetic sequence, we would write it as an is equal to a1, which is our first term, plus the common difference times n minus 1. So looking at this first example, we have a sequence 2, 5, 8, 11, 14. The common difference which is d, is going to be 3 because there's a difference of 3 from term to term. If I pick any two consecutive terms, the difference between them is 3. And the first term is 2. So when I write down my nth term, it's going to be an is equal to 2 plus 3 times n minus 1. I can check it by picking a term and plugging in. So let's say I want to find or verify that A4 is 11. So I have, this is my first, second, third, fourth term. Fourth term is 11. So if I plug in 4 for n, inside the parentheses I have 4 minus 1, which is 3. And 3 times 3 is 9, so I have 2 plus 9 is 11. So it works. So you can always go back in to make sure your nth term works by picking a couple of terms and checking to make sure that it works. In example 2, it looks like the common difference would be 1/3. If I keep adding 1/3, I get each term. No matter what two terms I pick that are consecutive, if I take the difference, it will be 1/3. My first term is 1, so when I write down my nth formula, it's going to be 1 plus 1/3 times n minus 1. In example 3, it says write the first 5 terms of the arithmetic sequence given the first term and the common difference. Well, if the first term is 19 and it says the common difference is 6, that means I just have to keep adding 6 to get the next term. So if I take 19 plus 6, that's going to give me 25. Then to get the third term, I take 25 and add 6 and I get 31. If I find a 4, I got to take 31 and add 6 again. That gives me 37. And to find a 5, I take 37 plus 6, which is 43. So my sequence, if I write down the first 5 terms, would be 19, 25, 31, 37, and 43, ... to show that it continues, and that is our list of terms. Now, if I want to write out the nth term, it's a1 plus the common difference times n minus 1. Since the first term is 19, and my common difference is 6, I would have 19 plus 6 times n minus 1. In example 4, it says, write the first 5 terms of the arithmetic sequence given the first term and the common difference. So this is the same thing as what we did before. I start with A1, which is 2, and I just got to keep adding 2/3. So when I take 2 and add 2/3, that's going to give me 8/3. When I take 8/3 and I add 2/3 again, that's going to give me 10/3. When I take 10/3 and I add 2/3, again, because that's my common difference, I'm going to get 4. And the last term, if I take 4 and add 2/3, that's going to give me 14/3. Now, if I wanted to write my nth term, it's the first term, which is 2, plus my common difference times n minus 1 in parentheses. In example 5, it says find the 8th term if the first term is 9 and the common difference is 8. Well, if I know the first term is 9 and my common difference is 8, I can come up with my formula for the nth term, which would be 9 plus 8 times n minus 1. And then if I want to find the 8th term, that means I just got to plug in 8 for n. So if I take 8 minus 1, inside the parentheses would be 7. And then 8 times 7 is 56. And then if I add 9 to that, I get 65. For example 6, it says find A1, which is the first term of an arithmetic sequence, if A13 is negative 61 and A25 is negative 115. So for this, we have to figure out what A1 is, the first term. We don't know what the common difference is, but we know that the general form for an arithmetic sequence is A1 plus D times n minus 1. And we can plug in these values to solve for A1 and D. So if I plug in 13 for n, I'm going to get A13, which is negative 61, is equal to A1 plus D times 13 minus 1. And 13 minus 1 is 12. So then I would have negative 61 is equal to A1 plus 12D. So there's one formula. Then I do the same thing and come up with the second equation. And then what we would have is a system of 2 by 2, where I have 2 equations and 2 unknowns, and we can use our information or our knowledge of solving 2 by 2 systems in order to solve for A1 and D. So I'm going to plug in now, negative 115 is equal to A1 plus D times n minus 1 in this case would be 25 minus 1 because this is the 25th term, so n is 25. And when I take 25 minus 1, that gives me 24. So my second equation is going to be 24D plus A1. Here's my second equation. So now I have 2 equations and 2 unknowns. So I can plug this in to my calculator to figure out what A1 and D is by using that program I showed you. So you want to make sure that you set up a matrix so that it solves the 2 by 2, and you put in all your values. So my coefficients, if I call this equation 1, my coefficient in front of the A1 would be 1, so I would put in 1, 12, and then my constant would be negative 61 that I put in at the end. Then for the second equation, I have a coefficient of 1, then I have 24 for D, and then my constant on the end would be negative 115. And then I would hit solve. and I would find that my A1, which is the x1 on the calculator, is -7, and my D, which is the x2 on the calculator, is -4.5. So that would be my common difference. So the answer to this question is that A1 is -7. And if I keep adding -4.5, when I get to A13, I'm going to have -61. And then if I continue to add -4.5, then when I get to A25, I'm going to have -115. For example 7, we need to find A5 given that A1 is 36 and A11 is -74. Well, in this example, it gives us half of what we already need to know. In order to come up with a sequence, or the nth term of the sequence, we need to know what our A1 is and what our D is so we can plug it in. If I know what the nth term is, then I can just plug in 5 for n and I can find my A5. But we already know what A1 is, so I'm going to put that in here. A1 is 36. So all I have to do is figure out what D is. And then once I know what D is, then I can plug in 5 for n into the nth term. Well, I can use the extra piece of information that they give me to plug in to solve for D. If I know A11 is -74, then I can plug in -74 for A11 and set that equal to 36 plus D times, since n is 11, I would have 11 minus 1, and I can solve this now for D. So I would have -74 is equal to 36 plus 10D, and then if I finish up here solving, I would subtract 36 from both sides. When I subtract 36 from both sides, I get 110 negative is equal to 10D. So D is going to be -11. So now I have my nth term formula. I know that A1 is 36. I know my D is -11, and then times n minus 1. So here's my nth term. Now to find A5, I just have to plug in 5 for n. So A5 is going to be whatever I get when I take 36 minus 11 times 5 minus 1. So 11 times 4 would give me 44. So I'm going to take 36 minus 44. And so my final answer is going to be -8. So A5 is -8. Okay, last example, example 8, it says find the 17th term in the arithmetic sequence below. They give us that A1 is -7, that's our first term. And then the common difference, if you notice, I keep adding a -3 to that. It keeps going down by 3. So my nth term is going to be -7 minus 3 times n minus 1. So now to find the 17th term, I got to plug in 17 for n. So I would have -3 times 16, because 17 minus 1 is 16. And then I'm going to add a -7, and that's going to give me a -55. So A17 is 55.